in absolute value. So let's say we have an example, y is equal to the absolute value of x minus 3 squared minus 1. And we want to see how we can graph this equation. First of all, if we take in x minus 3, the function in absolute value, let me take the absolute value here. Let's say we have a x minus 3, so I'm writing it the way how it is. X minus 3 square is minus 1, and here we have this function is going to be in the two intervals. In interval where is x minus 3 square minus 1, we have in the interval when is x minus 3. Let me write a complete here. Square minus 1 is greater or equal to 0. We take this part, and the other part is the same integral, but the sign is going to change here. We have a minus f of x. Here is a f of x is a greater or equal to 0, and minus f of x is smaller than 0. But f of x is in this case x minus 3, so I'm going to change the sign in front of the first term, x minus 3 squared. If I'm changing here, and second term I'm going to change the sign, of course, plus 1 because it's a minus f of x, and this is smaller than 0. And now to find the zeros, because the most important here is just to find the zeros of the quadratic function. First of all, I'm taking in this interval here, when, for example, x minus 3, let me take a different color. Then, for example, let me adjust this, x minus 3, if x in, I'm taking this interval, minus 3, square minus 1 is smaller or equal to 0. And now in this case we are just taking this part and we equate the 0 because we want to find the exact value, the zeros of the function. We don't have to use the operator greater or equal, but I'm using just the sign what it is here. Minus 1 is equal to 0. And now everything I'm solving for x. Minus 1 goes in the other side, become a positive, and we have a x minus 3 squared is equal to 1. Now I'm taking a square root of both sides. When I'm taking square root of both sides, x minus 3 is going to be equal with the plus minus square root of 1. Plus minus square root of 1. But we already know square root of plus minus 1 is going to be 1 outside, and a plus 3 I am adding both sides, this side and the other side I am adding plus 3, and if I am adding plus 3 both sides, plus 3 here, and x is going to be equal with 3 plus minus 1. 3 plus minus 1. In effect, 1x here is going to be 3 plus 1 is a 4, so x1, let's say, is equal to 4. And x2, 3 minus 1 is 2, so x2 is going to be equal to 2. So we found two roots. But because it's an absolute value, we have now to look for the other part, and everything what we have here, we are going to find 4 roots. And now I'm taking here another function, in another interval, the same function, minus 3x minus 3 squared plus 1 is smaller than 1. I'm taking x minus 3 square plus 1 is smaller than 1. Smaller than 0. So I'm taking the same thing, but what I'm doing here, I am just equating with a 0 because I have to find the values here, those zeros of the function. X minus 3 squared is going to be, and the other goes in the other side, is the minus 1. If I multiply everything by negative sign, both sides are going to be positive, and I'm taking the square root, and I'm getting the same thing like we did with the other equation, because it's all is the same. And in the end, I'm going to get a 3 plus minus 1. 3 plus minus 1. But because those are two other roots, so let me say x3 is going to be equal with the 4. 3 plus 1 is 4, and x4 is going to be equal with 3 minus 1 is 2. So as we see here, we have a repeated root. X1 and x3 is equal with 4, is repeated root. So that's why we don't have interception, but it just goes here and it jumps the graph of the function. Is it just touches the x-axis. Same thing we have with the x4 and x2. x2 is equal with 2, x4 is equal with 2. So here we don't have intercept. It's not the odd 0 of the root, but is the multiplicity is 2, because it's a multiplicity of 2. So the graph of the function is just touching here and jumps up. But the rest of the function, everything goes the same. We can for example, here create a table and can graph it this by hand, or we can use the graphing utilities and we can graph this function. So now is what happened if, for example, is with a plus 2. So the graph of the function is going to be just the positive side. This function doesn't have any zeros of the function, and the graph of the function is exactly the same as is without absolute value. So I am not doing here any exception. But when we have, for example, like this case, the function with absolute value, and this function is generated from the parent function, but is -1. It means it goes 3 units to the right and 1 unit down. But because in absolute value we don't have a negative function, and the reason is happening because we have repeated zeros of the function, or repeated x in the x-axis, those intercepts. We don't have intercept, but just the touches, and the jump is we have multiplicity of zeros. And in this case, for example, we don't have any interception. Everything is in the positive side. The function is a positive, is just on the upper side of the graph. So here, the graph of the function is exactly the same, like we are graphing the quadratic function without absolute values.